Welcome to your first project of the course. Based on what you have learned about publishers, subscribers, and interface types, it's time for you to apply this knowledge in this project. The project scenario is this. You have a mobile robot with wheels of a certain radius. One of the wheels has a rotary encoder sensor on it, which outputs how many rotations per minute the wheel is rotating. For this project, we will keep it simple and say the robot is going at a constant speed. The first node I want you to create is a publisher node, which publishes to a topic named RPM, with the sensor value that we are going to be publishing, in this case a constant value of your choice. Now, I have no idea how fast the robot is actually going unless I take into account the size of its wheels. So I want you to create a second node, which subscribes to the RPM topic, calculates the speed the robot is going based on its wheel size, and then publishes a result to the topic called speed. The speed for most robotic systems are in meters per second, but feel free to make it your own preferred units of measurement. So let's review what we are trying to accomplish in this project. In this project, we're going to be creating two ROS C++ nodes. The first is going to be responsible for publishing the RPM value that the robot wheel is spinning. So this node will have a publisher which publishes to a topic RPM. This topic then will get subscribed to by another C++ node that we will create, which will then publish the calculated speed based off of the RPM and the wheel size. Go ahead and pause this video and give yourself about 10 minutes or so to give this project a go. If you get stuck, you can follow along with me in the remainder of this video lecture, but I encourage you to try to work through this project. Alright, how'd it go? If you got stuck, you can follow along with me to see how I would have done it. So with my VS Code editor open, I can go ahead and create a new C++ file in our src folder, and I will call it rpm_pub.cpp. This node is just going to publish a constant number simulating the speed of our robot. So I'll actually go ahead and copy the code from the publisher we made in the previous lecture so that I can modify it for this project. You could also split your screen so that you could have the code side by side, but for now I will keep all the code on one screen so that you can see it better. The first thing I'm going to do is change the class name from Hello World Publisher to RPM Publisher so it makes more sense. So I can use the Ctrl-H keystroke to pull up the Find and Replace toolbar in VS Code. This way I can replace all instances at once. You can also pull this up by going to the Edit tab and clicking on Replace. So I'll replace all the times it says Hello World Pub Node and change it to RPM Pub Node. Then I'll change anything that has these double colon and string for our string message types to float64. So here I'll be publishing the RPM value as a float64 message. Then I will be sure to change my import from string HPPP to float64.hpp. As always, feel to double check the ROS index page on the standard messages package to see available message types. Then, last but not least, I will change all instances of Hello World to RPM, which will change things such as our callback function and our topic name. Now notice down in our message data we have an error, and if we hover over it, it says it does not know how to convert string to double. Well, for this node we plan on publishing a constant value for the wheel's rotations per minute, so I'll just declare a constant float at the top of the file called RPM value, and I'll just set it to something like 100, stating that the wheels are spinning at 100 rotations per minute. Then I can change the message data from our Hello World message to our RPM value. Now keep in mind, a float in C++ by default is 32 bits. So if we wanted this to be a 64-bit data type to match our message, we could use double instead. Just be careful if using the float32 standard messages message with a double variable type in C++, as you may lose precision. Now, this code still has the counter we had earlier, so I can delete all instances of it, since I will not be using it in this node. And with that, we are pretty much done with this file. We have a constant RPM value of 100, which will be published using the RPM pub node class over the topic RPM once every 1 second. There's one more thing I would like to add to this file, which is a print statement to let us know it is running. If you remember previously when we ran our nodes, it would just show a blank terminal. So let's change that by including IOStream and calling cout to print out a message saying our RPM publisher node is running. Great, with that, let's save this file and configure our CMakeLists text file to properly compile this new file. So I'll add a new executable by copying the one from before and changing the name to RPM pub. Now remember, you can always change the name of your executable to be something other than the file name if you want it. But for now, I will leave it as is, and I will go ahead and add it to our install targets list. Then I can go ahead and save this file, and we haven't included any new dependencies, so we shouldn't need to modify our package.xml file. So with that, let's check to see if our RPM publisher node works properly. So I'll go ahead and compile using Culkin build. And I'll go ahead and open up our terminal, change into our workspace directory. And we see the Culkin build was successful in our VS Code tab. So I'll go ahead and close that, head back to our terminal, source our workspace, and run the RPM publisher node. All right, with that, the node is running, and we can check by opening a new terminal tab and running ROS2 topic list. And here we can see our RPM topic, and we can go ahead and check the data by running ROS2 topic echo /RPM. And here we can see our RPM data of 100 being published. Great, the RPM node works. So let's create our speed publisher node. So I'll go ahead and minimize this terminal and right click on the source folder, start new file, and create a new one called speedcalc.cpp. The first thing our speed publisher node will have to do is subscribe to the value being published over the RPM topic. So I can go over to our old subscriber node from the previous lectures and copy it. So here I will change this class name from Hello World sub node to speedcalc node. Then again, I will change our message type from string to float64, so it matches the message type of my publisher, and include the float64 header file. Then I'll go ahead and change the node name to speedcalc node. Then I'll need to make sure the topic of our subscriber matches that of our publisher, which in my case is RPM. Now, every time we receive a message from the RPM topic, I want to calculate the speed the robot is going based on its wheel size. So I will change the name of our callback function so it makes more sense. In this case, I will change it from this sub callback to calculate and pub speed to better illustrate the purpose of this function. Every time this function runs, we will calculate the speed and publish the value over a new topic, which means we are going to need to make a publisher. So for clarity, I'll go ahead and rename this subscription variable to instead be RPM subscription with a trailing underscore. Then I will declare a publisher in charge of publishing the calculated speed value. Then up above, I will use the create publisher method of our node to initialize this variable. Now, if I take a look at my calculate speed callback, we know we are going to receive messages with the RPM value. So I'll rename it from message to RPM message for clarity. And I can delete all these printout statements from before, since we're going to be doing something different in this callback function. Instead, I'll need to create a new speed message variable, which will get published. And I just noticed my tab size was set to 4, so I'll go ahead and change that back to 2. Go back to my RPM pub node to make sure that it's also set to 2. Okay, that way it's a little bit more cleaner to read. Back to what I was doing in this code, I will create our new speed message variable, which will get published. in order to calculate the speed, I need to know the size of the wheel. For now, I will just declare a wheel radius variable at the top of our file. In this case, I will say our wheel has a radius of 12.5 centimeters. Since I want to calculate my speed as meters per second, I can convert this to meters by dividing by 100. Now let's go ahead and calculate the speed based on the RPM value we received from our RPM publisher and this wheel radius value, which we can use with the following formula. So to get the speed of the robot in meters per second, I can take the RPM, which is revolutions per minute, and multiply it by the circumference of the wheel, which will tell us how many meters the robot traveled per wheel revolution. Then I'll divide by 60 since there are 60 seconds in a minute. So now let's try to calculate speed using this equation and load it into our speed message. So first I will take the data attribute of our RPM message. Then I will multiply it by the wheel circumference. The circumference of a wheel is 2 times the radius of our wheel times pi. Now you could approximate the value of pi like I did here, or you can import the pi constant from the math library. Then last but not least, divide by 60 to convert meters per minute to meters per second. Okay, we calculated speed based off the RPM data and loaded it into our speed message variable. Now we need to publish this speed data using our publisher. Okay, great. Now let's review what's happening in this code. I created a subscriber which subscribes to the RPM topic. I also created a publisher which publishes to the speed topic. Go ahead and fix that. In my subscribers callback function, I take the RPM data and calculate the robot's speed. Then I load the value into the float64 speed message and publish it. Then last thing I will do is go ahead and print to the console that this node is running so we can visually see a response when we run the node in terminal. Okay, great. I'll save the file and head over to my cmakelists.txt file to include this file as an executable and in the install targets section. Be sure to save this file as well. So go ahead and save it. And I'll go ahead and build our workspace. And while that's doing that, I'll head back to my terminal and I'll clear some of these. And for clarity's sake, I'll go ahead and restart our RPM pub node. As always, going to make sure I source my workspace. And I'll go ahead and run our speed calc node. All right, so there we have it. We see both of these nodes running. So let's actually get to seeing what both of them are up to. So I'll open new terminals on the sides of each of these. And I'll go ahead and echo the corresponding topics. So here we see our 100 being published for our RPM publisher. And I can run the same command for our speed publisher. And so here we see our speed calc node is taking in the RPM from our RPM node and publishing out the speed value. I'll go ahead and stop this speed topic echoing for right now and I'll clear the screen. And if I actually go ahead and stop the RPM publisher node, so now our speed calc node should no longer be receiving messages from our RPM publisher. If I were to echo the speed topic, we actually wouldn't get any new messages because our speed calc node's not getting any new messages. So if I go ahead and restart up the RPM publisher node, the speed calc node gets it and starts publishing our speed out. So I'll go ahead and stop all of these from running. Congratulations! You successfully completed your first ROS2 C++ project, where you were able to take advantage of ROS publishers and subscribers to process data as you would on a real robotic system. Now, notice we had to hard code the values of the RPM and wheel radius into our code. So what happens if we want to use this code for robots with a different wheel size? Well, we would need to edit the C++ code and rebuild the entire project. Now that's not very functional. So in the next lecture, we're going to learn how we can use parameters to get around this issue.